Hello everyone, my name is Utkarsha and I am from the Buddhi Academy and I take your 10th standard maths and today's topic is real numbers. Now, let us first get an uh, introduction of the numbers. Now, what are natural numbers? Natural numbers are the numbers which starts from 1. 1, 2, 3, 4. The smallest natural number is 1. Then what are whole numbers? Whole numbers are the numbers which starts from 0. 0, 1, 2, 3, etc. Then, then comes integers. Now, integers are the one which include minus negative numbers and positive numbers as well. So minus 3, minus 2, minus 1, then 0, 1, 2, 3, and so on. Then you have real numbers. Now, real numbers, okay, before that you have rational numbers and irrational numbers. Now, rational numbers are the ones which can be written in P upon Q form where Q is not equal to 0. Now, like 2 upon 3. Now, 3. But we can write 3 as 3 upon 1, right? So, 3 upon 1. Then 6, 5 upon 3. Okay, these are all rational numbers. And irrational numbers are the ones which cannot be written in the form P upon Q. Like root 2, then 7 plus root 5. These are all which contains root signs are called irrational numbers. Now, real numbers are the ones which contains both, which has all decimal numbers, then like 1 minus 1.3, then 2 upon 4, then 868. Now this contain all real numbers, negative numbers, rational numbers, and this natural numbers, whole numbers. Okay, real numbers is the mixture of all numbers. So we are going to study about this real numbers. So let us start with our chapter. So we are going to do basically the main things which are going to come for the board exam, because right now your prelims are starting. So I just want to focus on the main things from the GOA board, from GOA board point of view. Then, okay. Now find the LCM. Now type 1 questions which can come in the GOA board, which is asked mostly. Yes, so find the LCM and HCF. We have studied about this LCM and HCF in lower classes of 144 and 60 by the prime factorization method. Hence verify whether, okay, this is an important statement, always formula. LCM into HCF is always product of two given numbers. Okay, what is LCM? LCM of these two numbers and HCF of these two numbers. Okay, when we multiply, we'll get the product of two original numbers which are given. Then we'll find this is 144 and 60, right? So we'll find the prime factorization first. Okay, if you cannot do directly how I do here, then you can see right here 144 and then always see large number is 4. So it is even number which will come in 2's table. 2 sevens are 14, 0, 2. Then 4 comes here, 2 2's are 4. If you cannot do it directly like I'm doing, you can go with the division. Okay, then here also last number is 2. Either you can go for division method or directly. 2 3's are 6, 2 6's are 12. 2 1's are 2, 2 8's are 16. Then 2 9's are 18, 3 3's are and 3 1's are. So your 144 is written as 2 into 2 into 2 into 2, 4 times 2, 2 3 times 2 times 3. Then which is the other number? Okay, 60. 2 3s are 6, 0, 2 1s are 5, and then 15, last number is 5, so it will not come in 2's table. So next table is 3. So 3 5s are 15 and 5 1s are 5. So your this expansion is 2 into 2 into 3 into 5. See, these were the expansions which we got from prime factorization method. Okay, now HCF is highest common factor. Now see, now we make this. Now this is okay. This is one pair, right? So which we take here, one pair. Okay, here that one pair is common. Now here also and here also one pair is common. But here there is no pair common. Then here and here there is one number 3 common. That's why we took this 3 also. Now for rest of the numbers we don't have anything common. Otherwise you can see this 2 common, this 2 common, and this is common. That's why we have taken 2 into 2 into 3, and that is 12. Now LCM is what? Okay, we multiply all these numbers. Okay, see, 2 into 2, okay, into 2, and then see, these two first, because they are common, we take only one. These two we take as 1 2. This pair we take it as one pair, 2, one number 2. Then remaining 2 into 2 which is here, we take this separately. Okay, which because they don't have any pair in the second thing. Here also see, 3 we take, first 3 is common here and here, right? 3. This 3 is separate, which doesn't have any this pair, and this 5 is separate. So that we get 720. Okay, so you got your LCM and HCF. Now, okay, first LHS. This is your LHS, and this is your RHS. Okay. Now LHS is what? LCM into HCF. So LCM is your this 12, 720, and HCF is 12. So 720 into 12 is 8640, and RHS, that is product of two numbers, that is original two numbers. Okay, that is 144 into 60, that is 142. In the question two numbers were 144 and 60, right? So that only we have written here 144 into 60, that is 8640. And yeah, so your LHS is equal to RHS is verified. So this is your first type of problem which we have solved. Then second time. Now this is very important in your further studies also, Euclid's division algorithm. Now, okay, what will be the question? By using Euclid's division algorithm, find HCF of 296 and 481. Now, you will be given two numbers. You have to verify which is the greater number. Now, see, 296 and 481, no? Yes. Okay. Now, 481 is greater than 296. So, 481 you have to take here equal to this 296 you have to take here into this, you have to keep it blank, plus this also you have to keep blank. Now, how we will find this is by division, right? 481 here, 296 here. Now this is normal division. How we do? Same thing we have to do. 296 ones are 296, because 296 into 2 will go beyond 500. 296. 5. This becomes 7. From 8. Okay, 185. Now here always you have dividend. This is your dividend, right? This is divisor, this is quotient, and this is remainder. Always it is like divisor into quotient. Quotient is 1 and remainder is 185. So divisor into quotient plus remainder. Then yes. Then this 296 we have to write here, and this 185 will come here, and same thing will do. We'll keep this as blank plus this also as blank, and then we will do the division. Okay, 185 into 185 will go above 300. Okay, so we'll do 185, 1s are 185. So this becomes 1, 1, 1. 1 and here 1, 1, 1. Then this you have to write here 185 equal to this you will write here 1, 1, 1 into plus 1, 1, 1 into 1 plus sorry, yes, okay, this, and then again 185, 1, 1, 1, 1, 1, 1, here 4, 7, 74, and 1 equal to 74 into 1 plus again 74, 1s are 74. Here you will get 37. So yeah, this is your 37. This will come here 74 equal to 37 into 2 plus 0. Now we have to go on till you get 0. Now we got 0 here. So your HCF is the first number. So HCF is 37. So yeah, you can see that. So these are your type 2 problems. If you want, you can take down this 2, 3, 7, 5 and 5, 5, 1. You can click a screenshot and then you can see. Okay. And the most important problems which are asked in the exams are this. Okay. Assuming that root 7, this is the question. Okay. Assuming that root 7 is an irrational number, prove that 5 minus 4 root 7 is also an irrational number. Now see, root 7 they have told you to assume. If the problem comes like only prove that 5 minus 4 root 7 is also an irrational number, then you have to always start with assume root 7 is an irrational number. Okay, always you have to start assume root 7 is an irrational number, this, and then here already they had given assuming that root 7 is an irrational number, you have to prove this. Now first let us assume 5 minus 4 root 7 is irrational. This as irrational we have to we have to assume. Okay, to prove anything is irrational, we have to take that as irrational first, so that then we can say when we will not get the proof correct, no, then we can say no, we are not getting the thing. So it is not possible to prove that it is irrational. Okay, now let this now if it is irrational number, no, then 5 minus 4 root 7 will be a upon b, where b is not equal to 0. I told you, no, rational numbers are the ones which can be written in p upon q form, where q is not equal to 0. Otherwise a upon b form, where b is not equal to 0, like this. Okay, so now we take this a upon b here, and this we prove We go to here, see. Always keep your root part positive. Always keep your root part positive. Now 5 minus a upon b equal to 4 root 7. It goes here. Now we will solve the denominator. Denominator is b. Now this 5 doesn't have this b in the denominator, right? This is 1. So we multiply 5 into b minus. This a has this denominator b. So we'll keep this as it is. That's how you get this 5b minus a upon b equal to 4 root 7. Then okay, this 4 we shift it here. Okay, so this becomes 5b minus a upon 4b equal to root 7. Now root 7 we took it as, okay, this root 7 we took as irrational number, no, assume, but here we are getting this as rational number. How can rational number be equal to irrational number? So our whatever we had taken, that is false. Root 7 will also be rational, but this contradicts the fact that root 7 is irrational. Now this word is the most important word here. Contradicts means we had taken that it is irrational number, right? But we are getting as this is rational number. So this is, whatever we are doing is false. That's why it is irrational number. Our assumption that 5 minus 4 root 7 is irrational is wrong. So that's why 5 minus 4 root 7 is also irrational. Okay. So these are the main 3 types of problem which are asked in the exam. Now this type, it is there in your syllabus, but it is not asked mostly. Still we will do that question. Okay. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. Now let a be any positive integer and be equal to 6. Why 6? Because this is 6. First it is 6, right? 6q, 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 that's why. Then by Euclid's algorithm, a is equal to 6q plus r. See, this 6q plus 1, we were taking no divisor into quotient plus remainder, same thing, 6, a equal to 6q plus r. For some integer, q should be, q is greater than or equal to 0, and where 0, r lies between 0 to 6. So if r lies between 0 to 6, your possible numbers for r can be 0, 1, 2, 3, 4, 5, because this is strictly greater and this is equal to, greater than equal to. Okay, then a can be 6q or 6q plus 1 or 6q plus 2 or this forms. Okay, this forms it can be, because r is strictly less than 6. So a is equal to 6q, 6q plus 2 or 6q plus 4, then a is an even integer. Also an integer can be either even or odd. Therefore any odd integer is of the form 6a plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So we are done with your real numbers. So thank you for watching my video. Do like, share and subscribe.